Let's talk about errors in Excel and how we handle them. Error messages are just part of using Excel. We're human beings. We screw things up, error messages pop up. The sad thing is most users have no clue what these error messages are even trying to tell us. On the screen is a list of the most commonly encountered error messages. Now, some are more common than others, and there are more than are in this list, but these are the ones you've probably seen. If you've ever wondered what's causing these errors, this list explains why the error occurs, and in some cases a formula that would trigger that error. Now, I have all of this in a downloadable PDF file that actually goes into even greater explanation if you're interested. You can download those PDFs from the link in the video description, as well as this file that has all of the formulas built for you so you can go in and just copy-paste them and then adjust them to your needs. But when it comes to handling the errors, almost every user is taught about one, if not two specific functions, the if-error function and the if-NA function. These functions allow you to test for an error, and if the error occurs, capture it and replace it with something a little more human-friendly. For example, if I performed a lookup operation and didn't find the item, instead of returning a $NA error, I could return something like item not found. Although the if-error and if-NA functions are great functions, they have a serious limitation. They can't distinguish between the type of error they've detected. Let me give you an example. If I were to run an if-error function that points to that first column of error messages, in every instance, if-error detects that that is an error. Notice in my formula bar, I've said, if this is an error, place the word yes on the screen. So every one of these is being triggered, capturing the original error message and replacing it with the word yes. If I do the same thing with the if-NA function, if-NA will only detect the presence of an NA error message. Every other error message will just be displayed as natural. Although I'm just placing the word yes on the screen, what if you'd like to have a more descriptive error message, like item not found or invalid value? Certain functions can return different errors depending on what the source of the problem is. A lookup may return a $NA, where a division function may return a $div0, and a text value that breaks arithmetic operations would return a $value. The good news is that every one of these errors is associated with an error number. In the second column of this table are the actual underlying error codes for these error messages. What if we had a function that could examine or test the error code and then display a different message depending on the value of that code? This is where the ERROR.TYPE function comes into play. Let's look at an example where a single function can return different error messages depending on what the problem is. I have a table that has a list of colors and a list of prices. The object is for the user to pick one of those colors from a dropdown, type in the number of buyers for that color, and then divide the price by the number of buyers to see the price per buyer. I'm using an XLOOKUP function to do that lookup, then the return price is divided by the value entered in cell F5. Well, what if the user, instead of accidentally typing in a number of buyers, types in a buyer's name, like Fred? We're going to get a value error message. What if they type in 0 as the number of buyers? We're going to get a divide by 0 error message. But what if they enter in a color that's not in the list? Well, then we get a $NA error message. We'd get the same thing if they entered no color at all. Well, each one of these errors is returning an error code. So our $NA is returning a code 7. I'll give it a proper color. 0 as the buyers. Divide by 0 returns an error code of 2. Fred as a number of buyers returns an error code 3. So let's test the error code and then have a different response depending on that code. Remember I said earlier that most users are taught to deal with custom error messages using the if-error or the if-NA function. If you're not familiar with these functions, here's an example of how they're used. If you're already familiar with these functions, you can go ahead and skip to the advanced test portion of the video. Using if-error, if-NA, and XLOOKUP's native error checking argument, here are the three formulas. I've wrapped the XLOOKUP inside an if-error and said if it's an error, display numbers only. I've also wrapped the XLOOKUP in an if-NA that says if we encounter an if-NA, display the error message invalid color. And if we use XLOOKUP's native error checking argument, we'll display color not found if an error is encountered. So as before, if I go to the number of buyers cell and I type in Fred, if-error tells me you're only supposed to put numbers here. But if NA wouldn't understand that and just returns the generic pound value error. Same thing for XLOOKUP's native error checking argument. If I were to type in a 0 for the number of buyers, if error returns numbers only, but 0 is a number, so that really is a bit confusing. And if NA and XLOOKUP don't understand the problem and just return the standard divide by 0 error message. If I were to select a color that's not in the list of available colors, if error erroneously displays the error message numbers only, makes the user think I'm supposed to type a number in here. If NA, however, does display the invalid color message, which is helpful, but XLOOKUP's native error checking argument doesn't understand any of this and just displays the standard pound value error. So in all of these scenarios, there's a combination of successful error messaging and unsuccessful error messaging. Incidentally, the reason XLOOKUP's error messaging doesn't work is because the moment you use XLOOKUP with an additional mathematical operation, you can't use the built-in error checking because that custom error messages gets fed into a mathematical formula, which is what generates the pound value error. It's now time to see how we can create custom error messages based on error type. If I go back to my error types page and click in the second column, you can see in the formula bar I have a function called ERROR.TYPE, and I'm just pointing to the cell directly to the left. ERROR.TYPE is going to give us targeted professional grade error handling. ERROR.TYPE is better because where if error collapses all errors into one action, ERROR.TYPE will support branching logic. And where if NA only handles lookup problems, ERROR.TYPE will handle all Excel error types, not just pound NA errors. This gives us professional error reporting, which is critical for things like dashboards, data validation pipelines, financial models, shared corporate workbooks, user-facing calculators, or training tools. In all of these cases, ERROR.TYPE looks at the error message and returns a code number. My guess is that your first thought is to create a nested if formula, to say something like, if it's code 2, display the message you can't use 0. But if it returns code 7, you could return something like color not found. And maybe pound value could return something like, please enter a number. I have 4 options for you to decide which one you think is easiest to implement this multi-error messaging scenario. We can do this as a nested if, and I have 2 versions of this. You'll see why in just a moment. We could also perform this with an IFS function or a switch function. Here is the nested if version. Now this to me is the most cumbersome and complicated version of them all, and I would avoid it at all costs. But if you didn't understand what I'm about to show you in the other versions, this is how you'd have to do it. Now at its core, we have 3 ifs that test for error code 2, error code 3, or error code 7 using the ERROR.TYPE function, and they display different messages. Error code 2 says cannot divide by 0, error code 3 says invalid number of buyers, and error code 7 says color not found. If we encounter an error that's not one of those 3, then we just display the generic other error message. The big twist in this is if there is no error, you actually need to perform the calculation. So we have to run the XLOOKUP, wrap it inside of an is error to test to see if it's an error. But really what we're trying to do is test if it's not an error. So if it's not an error when you perform this XLOOKUP divide by 5 operation, go ahead and perform the XLOOKUP divide by 5 operation. If you haven't already noticed, we're performing the XLOOKUP 5 different times. We're also performing the ERROR.TYPE check 3 different times. That's an excessive number of repetitive calculations. Not to mention that the formula is incredibly complicated. We can greatly simplify this by using a let function. So I've taken all those nested ifs that test for, is it not an error? Is it error 2? Is it error 3? Is it error 7? Is it something else? And I've placed them inside this let function. If you're not familiar with the let function, it's a way for you to create variables within a formula. This is especially useful when you're performing the same operation repeatedly. So what we're going to do is we're going to let the word calc represent that XLOOKUP divide by 5 calculation. So if I ever need that particular formula, I just say calc. Likewise, we'll create another variable called ET for error test. And if ever I want to perform the error test, since it's the same test every time, here's what that error test is. And now I can just say ET whenever I need it. These 2 calculations occur one time only, and the results are stored in the calc and ET variables. This greatly reduces the repetitive nature of those formulas. Now our if statement is much easier to understand, so we can say if the error test result is 0, then display the result of the calculation. But if the error test is a 2, show cannot divide by 0. If the error test is a 3, show invalid number of buyers. And if it's error 7, color not found. Finally, if you've made it this far and nothing is ringing true, just put the words other error on the screen. We're still using that 4-level nested if, but we're not performing any calculation more than one time. Plus, we didn't have to do the whole if not is error routine. A way to make this even simpler is to use an IFS function. If you've never used the IFS function, IFS was created to reduce the complexity of these multi-level nested ifs. We're going to put this in a let function so we can declare those variables like we did before. So the calc variable will execute the XLOOKUP, divide by 5, store the result in calc. Error test, or ET, will perform the error type discovery, and if there is no error, then it just stores a 0. Next, we launch an IFS, and we just ask a series of very simple questions. If error test, or ET, is a 0, show the results of the calculation. If error test is 2, display cannot divide by 0. If error test is 3, display invalid number of buyers. And if error test is 7, display color not found. If we've made it this far, and we haven't hit a true scenario yet, then go ahead and display the message other error. So if you're a fan of nested ifs, but don't want the complexity of nested ifs, consider an IFS function. But don't perform the same calculation repeatedly. Place your IFS function inside of a let function so you can declare those variables, execute the formula one time, and just save the answer in the variable. Finally, the switch function. Think of the switch function as an even simpler version of the IFS function. In the IFS function, we had to declare exactly which variable we were testing every single time we tested. The switch function says, here's what we're testing, now check for all of these things. So beginning with the let, we declare two variables, calc and error test. And then switch says, looking at the error test variable, is it 0, 2, 3, 7, or something else? If any of these ring true, we display the appropriate response. If none of them are true, then just put the words other error on the screen. So if you've never used the IFS function before, here's your chance to make simpler nested if formulas. And if you've never used switch before, now here's your chance to make even simpler ifs. Let's test each of these solutions. If I go to the number of buyers, I type in Fred, every one of them says invalid number of buyers because they're each returning an error code 3. If I type in a 0 for number of buyers, each one of them returns a cannot divide by 0 error message because they're all detecting an error code 2. I'll put in a proper number of buyers. And if we enter an invalid color, each one of them returns the color not found message because error code 7 was returned. And if I did something silly like mistyped my function name, in this case XLOOKUP, all of the formulas return the other error message because this generated a code 5 and that wasn't tested. And now we know why ERROR.TYPE is superior to IFERROR and IFNA. So use ERROR.TYPE when you have to differentiate between errors, you need different handling for each error, you're building diagnostic messages, validating user-entered inputs, or you just want granular control over your formula's logic. So let me know in the comments what you think about all these different types of new errors that you may never have heard of, and which way would be your favorite way to deal with them. Old school nested ifs, or using the let function with nested ifs, the ifs function, or the switch function. And don't forget to download these files from the link in the video description, and PDFs with fully detailed explanations of each of these error types with examples. Thanks for watching, and remember at BCTI, the learning never stops.